Hello everyone, welcome back. Here is VanAmsen, and in today's video we will solve daily LeetCode challenge, key radius subarray average, this time in Go. So we will do a efficient solution, so with a rolling window. And quickly recapping the problem, we are given a zero index array of integer and a key integer, and our task is to build a return an array where each index holds the key radius, so from key to the left and right of the array, with averages for the sub-array centered at that particular index. So we will do it with rolling window efficient solution in Go. So let's implement it. So first, we initialize n as len of num, and averages make it int of n, and for I in range averages at e will be -1, and window size will be 2k plus 1, and if k is 0 we return nums, and if window size is greater than n we return just averages. So two boundary cases, and window sum will be 0. So for e less than window size, increment and window sum will be plus num. So averages will be window sum divided by window size, and for I, window size less than n, increment and window sum will be window sum minus nums I minus window size plus num at I. So averages I minus k will be window sum divided by windows size, and we finally return averages. So this is our implementation. So let's run it to see if it's working. Hopefully it worked in Go. So yeah, it's working. So everything's perfect. And also, yeah, boundary cases work as well. So for yeah, key being 10,000, so -1, and also like if array contains key of 0, so two boundary cases covered, and also the tricky one or normal one. So let me explain what we did. So earlier we solved this problem using a brute force approach. So brute force approach will be just rolling down the window and making simple sum, but it could be a time limit out of exception, so you get out of your time. So we need to think of something more clever. So we tried to reduce complexity from O(n) times key to just O(n) with window rolling slide that will make this approach much more efficient. So let's jump into our code and explain a solution. So first we initialize our average array of size n with -1. So all are -1. And then we initialize our variable windows size to 2k plus 1. So it's basically the sliding window. And we handle both edge cases. So key is 0. So when key is 0, we just return nums. And if window size is bigger than our array, so then we cannot calculate it, and we return averages. So array just with -1 we initialized before. So yeah. And next we calculate the sum of an initial window and store this in a Windows sum. And then we calculate the initial key radius average and store it in our average radius. So here is initial value of average at element key. And then we do like the base trick to make it more efficient. So moving forward, we iterate through the rest of the array, shifting our window to right by one element at each step. And for each new window, we update window sum and calculate the new key radius average, which we then store in our averages. So trick here is just to slide the window to the right. And what we do, we remove one element from the back of the sliding window sum and add it to adding one at a front. So basically, we do not recalculate the middle part of our window sum. So it's really efficient because, for example, if you have key of, let's say, 100, so you basically have like one new element. So why to calculate like whole 100 elements if you can just like remove one from the back and add one from the top? So basically, you just do less operation rather than adding every 100. So we take use of previously calculated window sum and then just divided it by window size. So it's make the solution really optimal, I can say, because it's working in linear fashion. And yep, so I ran it for unseen test cases and we beat 78% of memory, and also with respect to runtime, 69%. So yeah, really good. And I hope you like this video and subscribe for more coding tutorials, solutions, and much more for Go programming language to become even better programmer. And as usual, stay motivated, keep practicing. Happy coding and see you next time.